Hello, hello, hello. This is the stream where we catch up on the advent of code. And we have solved up to day 8, and then we stopped because we were busy doing the baby jam. So now we need to continue solving these problems here. All right, let's see. Day 9. Day 9, Day 9 Mirage Maintenance. You ride the camel through the sandstorm and stop where the ghosts maps told you to stop. The sandstorm subsequently subsides, somehow seeing you standing at an oasis. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be yet another giant floating island, this one made of metal. That must be where the parts to fix the sand machines come from. There's even a hang glider, partially buried in the sand here. Once the sun rises and heats up the sand, you might be able to use the glider and the hot air to get all the way up to the metal island. While you wait for the sun to rise, you admire the oasis hidden here in the middle of Desert Island. It must be a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone, so the oasis can be around for the next sandstorm-worn traveler. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they are changing over time. Your puzzle input. Each line in the report contains the history of a single value. For example, it means that the first value goes from 0 to 3 to 6 to 9 to 12 to 15. To best protect the oasis, your environmental report should include the prediction of the next value in each history. Do this start by making a new sequence from the difference and each step of your history. If that sequence is not all zeros, repeat this process using the sequence just generated as the input sequence. Once all of the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. In the above that said, the first history is this. So like the deltas are 3, 3, 3, 3, 3, and then the deltas of this sequence is all zeros. So we know that the next delta should be 0, should be still 3, so the next should be like 18. Right? So we can do it like that. Extrapolate, adding a new 0 to the end of the list of zeros. Yeah. You can then start filling in placeholders from the bottom up. B. I mean, all right. This is understandable. This is easy. So now we just need to do this, right? Analyze your Oasis report and extrapolate the next value of each history. What is the sum of these extrapolated values? All right. Understood. So this is the example. Day 9. Example. And then we have the actual day 9 here. Let's start coding. Like, we can start by doing the straightforward solution. I'm assuming it's going to work. Even though it probably can be done faster. But let's start with doing a straightforward one. We need to solve like 5 days of Advent of Code today. All right. So what we do is get the input. So input is going to be a list of sequences, and every sequence is just a list of numbers, right? Let's say that those are I64s, for example. So this is going to be read to string J9 example, right? Unwrap. We take the lines from there, and then we map every line to split white space, and every single token is going to be parsed into a number, unwrapped. After that, everything is going to be collected, and all the lines after mapping also are going to be collected, and this is it. This is our input. Okay. Now that we have the input, cargo run bin J9, right? Now that we have the input, no such file or directory, by the way. It should be input/J9. There you go. So now that we have the input, we just need to solve and extrapolate for everything, right? So let's see. We're going to have function. So this is extrapolate, right? For a sequence. Let's call the sequence A, whatever. It is going to be just a list of numbers. We take a slice, and then we extrapolate what is the next number should be, right? Like this. So we do answer is going to be equal to input for every single input. This is like the sequence. We extrapolate every one of these, right? Wait, there is a method called in as slice on the iterator, is that right? Iterator to slice, nice. Anyway, we take the iterator, and then we extrapolate it. We just need to call it manually here because this is a reference to the VAC, and we need to like get a reference to the slice. All right. So we extrapolate, and then we add those together, right? And that's our answer. That's what we need to do. Now we need to figure out how to actually extrapolate these things. I think we're just going to do it straightforward, just like they did it here, right? So we figure out what the next thing should be, and only thing we know is that if all of the values are zeros, then the next value is 0. Otherwise, we need to take the deltas, extrapolate the next thing, and then add that to the last value, right? So we do something like this. If a all equal to 0, apparently that's a method from itertools, right? All equal. Oh wait, that's just all equal to that's just all of them are equal. Okay. All equal value. If there are elements and they are all equal, return a single copy of that element. Good day. Hello, Brainoid. How are you doing? I do the advent of coding today. Oh, equal value. I guess I can use this API. I mean, if all of the values are equal, so if they are all equal to the same value, then the extrapolated value is going to be the same. So we just return that value. Right? Am I self-taught? Well, not entirely. Not entirely, but mostly, I guess. Hello, Maxwell. What exactly? Like, it depends on, like, what exactly are you asking about? There are many things that I have learned. Some of them I learned myself, some of them I've been taught. Okay, anyway, so if all of the values in over there are equal, right? Let me make sure that we take the actual value, then the extrapolated value is the same. Otherwise, we want to take the deltas, right? Deltas. Can I do this actually? Hold on. We do a iterate. We do like windows of size 2 is what we want, right? We want to take the windows of size 2. But I guess we can... Maybe something from itertools is going to be better. Iterate tuple windows, I think is what we want. Did you do a degree in computer science? I did not finish my degree, but yeah, I don't think university was very helpful anyway. Hello, Rinks. But I did do competitive programming. That was useful. But most of my like regular programming, I guess, was self-taught. Is what you can say. Your stream is my most watched stream of 2023? No way. Hello, Bad Cop. Day 9. Indeed, yes, this is day 9. I just started. We have 5 days to solve today. How long do you think it's going to take me? Am I based in the US? No, I don't. I'm not based in the US. Just want to know if it's realistic to self-teach in UK and get a job. I'm pretty sure if it is realistic, yes. Pretty sure it is realistic, but I mean, I'm not sure exactly because I did not really try to apply for a lot of jobs. Maybe Bad Cop can tell you more about it. I'm not sure. Or some other people in chat know more things about actually getting a job. What is this? What is this? All right. That's a ring scrab. Nice. So you are using your own emotes less than my emote and Rink's emote, is that right? Nice. Does established company already using Rust for their business? Wait, what? Does established company already using Rust for their business? I mean, there are companies that using Rust, if you... That's the question. From what I have heard, for example, in Microsoft, they have a policy that new projects are studied in Rust instead of C++ now. But still, getting a job in Rust specifically is probably harder than in other languages. Anyway, let me solve this. We're trying to extrapolate this here. We have a list of numbers. We want to extrapolate the next numbers. If all the numbers are the same, then we return this same value. Otherwise, we take and calculate all the deltas. We iterate. We get the tuple windows, which we are going to map every tuple of A and B into B minus A, right? That gets us the delta, right? We collect that into a vec, right? Collect that into a vec, and this is the deltas. So we are going to extrapolate the deltas to get the next delta, right? And then we are going to say something like a. So I'm going to take the last element, right? I'm going to take the last element, and I'm going to add to it the next delta that we have just extrapolated, and that's like the next value, right? And I think that should be it. That's the entire thing here. Let's see. So this is the answer for the example, 114. Is that correct? It is correct, right? Let's run this on the actual input, day 9. The output is this. All right, let's submit that and get the part 2. Part 2 is, of course, it would be nice to have even more history included in your report. Surely it is safe to just extrapolate backwards as well, right? For each history, repeat the process of finding differences until the sequence of differences is entirely zero, then rather than adding a 0 to the end and fill in the next values, you should instead add a 0 to the beginning and then fill the new first values. In particular, there is what a third example. All right, adding these new values to the left side, doing this for the remaining example, -3. So the only difference is we now extrapolate the previous value instead of the next value, right? Okay, sure. This is part 1. And this is going to be part 2. This is like the easiest thing ever, it seems. Right? So in order to extrapolate, if all is saying that it is the same, otherwise we get the previous delta, and instead of taking the last element and adding the next delta, we're going to subtract the previous delta from the first element, right? What's my summary? Hold on. I can take a look, I guess. Day 9, part 2. So I got a 2. All right, and then we get the actual thing. And the answer is 1019. That's the right answer. That's like the easiest like transition from part 1 to part 2, I think, ever. Hello, Code Monkey. All right, how do you see this thing? How do you see this? It was at the bottom, but then it is Twitch recap over here. All right, let's see. All right. Your top stream reached 277. 120,000 chats sent. That's like, wait, hold on. This is just for me as a streamer, right? My top 3 tags: English, Crab, and Rustlang. My emotes. These are the emotes that are being used. The kek, obviously, the best one. All right. Your new followers. So most of my followers were this year, because this is basically, I started streaming like a year ago, right? Like constantly. How many what? How many keks? 3,000 keks has been used this year. So this is like on average 10 keks a day, I guess, right? Oh wait, no way fish is used less. No way fish is used less. I guess people use exclamation mark fish instead of the emote, right? Okay, what else do we have? Hours watched. Minecraft? Oh yeah, but that's when we played Minecraft with Bad Cop, I guess. Alright. Choose another recap. Viewer? Alright, do we want to see Rinks Clap and Rinks Craft Jam and this? I'm not really like very active in chats though. $11,000. So hold on, this is how many messages I have sent in chat. Is that right? 11,000. All right. I guess most hours have been watched on the Jitspo channel. Kobe Boy, and then Bad Cop, and then Rinks, and then Cakes. Since Kobe Boy is here, what happens if I go to the Kobe Boy and see Kobe Boy's recap? Where is it? Over here. Hans. Alright, anyway. While we are recapping, you should rewatch this. What is this? The world's greatest gamer. Don't bother with community? What is community even?
What? What?
Why is there no audio?
What?
Oh wait, there is audio. I'm just not hearing it. Alright.
I was putting down the lava so that I can pick up the water, you know, because I need water to create a portal.
Yeah, this is 5 minutes. What operating system is this? I'm using Nix OS. You realize the Kobe man rip. Alright. Yeah, Minecraft was fun. Alright. Maybe we do this again sometime. But today we're doing the advent of code, alright? Operating system is over there. Day 10 is the fun one? Alright, let's get to the day 10 because... Fun. I like fun. Alright, pipe maze. Alright. What is this? Day 10 pipe maze. You use the hang glider to ride the hot air from Desert Island all the way up to the floating metal island. This island is surprisingly cold and there definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander a lot around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled hot springs, pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. You know what? Like, I'm reading this like story and I don't remember anything. Like, we have solved like 10 days of this, right? I put your crime in the game and you didn't submit Honest Gem. Oh, Brainoid, yeah. I don't know. I decided not to submit my game for the Honest Gem. I was working on the game after Honest Gem finished, fixing some of the bugs on the last day of the Baby Gem. I am obligated to write visualization when you beat day 10. Okay. We'll see about that. The landscape here is an alien. Even the flowers and trees are made of metal. As you stop to admire some metal grass, you just notice something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you have ever seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they are the same metallic silver color as the ground. You make a quick sketch of all the surface pipes. You can see your puzzle input. The pipes are arranged in a two-dimensional grid of tiles. This is a vertical pipe, this is a horizontal, this is a 90 degree, this is a 90 degree bend this way, this way, this way. Dot is the ground, there is no pipe in this tile. S is the starting position of the animal. There is a pipe on this tile, but your sketch doesn't show what shape the pipe has. Based on the acoustics of the animal's scurrying, you are confident the pipe that contains the animal is one large continuous loop. For example, here is a square loop of pipe. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. In the above diagram, the S tile is still a 90 degree F bend. You can tell because of how the adjacent pipes connect to it. Unfortunately, there's also many pipes that aren't connected to the loop. This sketch shows the same loop as above, but there's also some additional pipes. I see. In the above diagram, you can still figure out which pipes form the main loop. They are the ones connected to S. Pipes those pipes connect to, pipes those pipes connect to, and so on. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly two pipes connecting to it. Here's a sketch that contains a slightly more complex main loop. Here's the same example sketch with the extra. If you want to get out ahead of the animal, you should find the tile in the loop that is furthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting point.
Hello?
Hello, Nerdsoul. What if there is two things like that? I guess it's never going to be two because we are on rectangular grid and we only go to the side and to the up. So the length of the loop is always an even number. So there's always going to be one that's exactly in the middle, right? You can count the distance. Each tile in the loop is from the starting like this. Yes. This example, the furthest point is 4 steps away. Here's the more complex loop again. Here are some distances. Find the single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point furthest from the starting position? All right. I mean, this is simple. Getting better at reading games? Yeah. I'm practicing some reading here. Some math formula to solve this. I mean, this is straightforward. You just go find the S, go find the start, and then you find the loop, right? By going in any direction and then following this direction until you hit the start again. So now you have found the loop, you have found all the positions, and you now like take the middle position. Someone was calling this one DFS, but that's silly. Well, yeah, it would be a DFS if it was not just one loop, but because it's just a loop, you just do a loop to find it instead of a recursive thing. Let me DFS on this linked list. Yeah, I guess. The only thing is like the starting point can technically be connected to like from all the 4 sides, right? Or is that not the case, actually? I guess let's just take on the puzzle input and let's see So where is the S here? The S is over here, right? Actually, no. The S is actually connected only to two things, to the top and to the left one. It specifies that it only connects to two. I thought it was like saying that, like, like if you replace the S with an actual like thing that was there in terms of the pipe, then it would only be connected to two. But yeah, all right. Then it's even simpler because there's, yeah. All right. What do you need the visualization for here? I mean, we can do the visualization, but why? J10. What's which one of these is the example? This is the example, and the answer is 4 here, right? And this is the same, but like a little more complex with like unused things. But it should not matter. Part 2 is the visual part? Alright, we'll see. We'll see. J10. So map is going to be, let's do the map as vac of chars, maybe. Sure. Can you solve it in Factorio, please? What do you mean solve it in Factorio? Am I supposed to like parse the map and then like put the map as a and convert it into a Factorio save or what? Hello, Arya. Okay, we need to find the position of the S. S position is going to be to have the row and the line, the index and the row, and then we do row, iterate, enumerate. I mean, we just do the find map here. We just want to find the position. And then we do here find map. If in the row the character is S, then we return the row and column, right? Otherwise, we don't. Let's do it like this. So this should allow us to find the position of the S, right? It should be there, so we can unwrap this safely. Now that we put the crab in the pipes and let it find the way. Hold on, I don't know what we need to do in the part 2 yet. Are you doing the Advent of Codes too, Brainoid? Hello, Pigorly. Okay, so we have found the start, and once we found the start, we just need to find the loop. So loop positions is going to be a vac. I guess we just start with the start position, right? Okay. So I also want to know the previous one, right? All right. Let's do this. We have the current position is going to be S, and the previous position is going to be none, and then we do something like barely finished your honest gem game. Now back to Kattenberg. Yeah. Need to go back to Linksider too soon too. Okay, so we're just going to go in a loop, right? We're going to find the next position that we need to go to. So let's see. Directions is going to be a list of directions, of 4 directions that we can go, right? Which is going to be -1, 0, 0, -1, 1, 0, 0, 1. Those are the 4 directions that we need to check from this starting position, right? Well, I guess, hold on. It depends on whether... Oh, right. If we are currently on the starting position, then we want to try all the different directions. Otherwise, we want to go in the direction that is opposite from the previous one, based on the current character, right? And you to play my game and create some levels, by the way? Alright. I can do that, I guess. Maybe after this. Maybe after day 10. Okay, anyway, we just want to find the thing that we are connected to here. You in plural, hi chat. Oh, I see. Everyone gonna play Brainoid's game. Hold on, I'm also interested in the input. Can it be that we, as as the middle of the pipe, are also connected to more than 2
You wanted to see me?
other pipes? Like the things that are like trash, that are not part of our loop, can they point in the direction? I guess they can. Like this one is pointing towards us. Okay. So I also need to like make sure. Okay, so directions. Hold on. This is all directions, and I also want the directions based on the character. Character directions. Let's just do a hash map, for example. So I'm going to do for the F, we can go right and we can go down, right? So it's going to be right is 0, 1, and down is 1, 0, right? So for every character, it'll store the 2 directions that we can go from that character, basically. Right? And there is this many. For this one, we have 0, 1, and 0, -1. This is going to be a hash map from character to two directions that we can go. Let's go in the same order as actually they are doing here, you know? Probably makes sense. Let's see. We have the vertical one, which is going to the next row and the previous row. We have the horizontal one, and we're going to have the L, which goes to the previous row and the next column. All right. We have the J, which goes to the previous row and previous column. We have 7. 7 is going next row, previous column. Then we have F, which is next row and next column. And then we have dot, which is nothing. And then we have S, which is the start. Okay, so this is all that we need, actually. All right. Okay, and this is basically like all the directions. This is like all the directions. Right? So we are going to find the loop itself. We are going to find the loop itself. Loop positions. Right? Which is going to be just a vec, I guess, right? Here's what I'm going to do. I'm going to actually just do a while. Loop positions does not contain the current position. We are going to insert it into the loop position. Current position. Right? And we're going to go from the current position to the next position based on the previous one. We're going to say that previous and current position is equal to the current position, and over here we need to find what is the actually next position is, right? So how do we figure out the next position we need to go to? It's based on the previous one, I guess, and the character. So I guess here's what we're going to do. We're going to say that if... So first find the character. The character at our current position is going to be map position 0, position 1, right? This is the actual character. So if character is equal to S, then I'm just going to find anything that's connected to it, right? So for so I'm going to, out of all the directions, I'm going to do the find map. This is the direction. The position next to us is going to be position 0 plus direction 0, position 1 plus direction 1. So we need to find the character at that next position, right? Right, and we want to find the directions that next character is connected to. So like connected, it's going to be char directions get for the character at the next position, for the map at next position 0, next position 1. I guess this also, because we can be on the edge of the map. Let's make a closure here, something like character at is going to be a closure which takes the position in a form of 2 i sizes, so that I can go negative basically here, and this returns optional character. So over here, this is going to be character at position, right? How do we calculate this here? If position 0 is less than 0 or position 1 is less than 0, then we return none. Otherwise, we do map get position 0 dot get in 1. Copy it. I guess. All right. Mismatch types. Found tuple usize. Position. The S is usize. All right. I want to convert that to isize because I want to be able to go negative here, I guess. All right. Now, if we are at the starting position, then we find the direction, which has the character next to it, right? And we get the things that are connected there at the next character, right? And I want to guarantee that we are there. So the connected, we should be connected. So this should contain the opposite direction. So negative direction 0 and negative direction 1. So we can go back from the character that's next to us, right? And in this case, we are going to return the next position, right? So that's our next position. We can unwrap here because we are always connected to exactly 2 things, but we just take one of those. All right. So, and then we do, if we are not at the start, then we know the previous position, and I want to figure out what we are currently connected to. So connected to is going to be character directions get for the current character that we're standing on, right? We can unwrap this here, and then we do connected iterate. I just want to find the one that's not equal to the direction we came from, basically. So the direction that we came from is going to be, let's see, previous is going to be previous unwrap, because if we are not at the start, that we have came from somewhere, and then direction is going to be current position minus previous position, right? That's our direction. So I want to find those directions that are not equal to the direction that we came from. I guess this is the direction from previous to the current one, and I want to find the opposite here. So this should not be equal to negative direction. And then there should be only one other thing, and that's the other direction, basically, what we need to go to. All right. And once we know the other direction that we need to go to, we are just going from the position to the other direction. Like that. Is that it? This is expected reference to the character. I mean, yes. Hold on. Arguments to this method are incorrect. Expression. Oh, character at position obviously is not none, so I can unwrap it here. Previous, I need an explicit type. So this is the position. So also a tuple of that type, right? And then loop positions needs to be mutable. All right. So now we have found the only thing that's like not very performant here. I guess I am checking if the position was not visited before by iterating through the entire VAC. We could do it instead with like a hash set faster, but I don't think it matters for this. Filter next is literally the same as find true. True. I can copy this so that we don't have a reference. All right. Okay, now that we have found the loop, we just want to find the thing in the middle, right? So, and what do we need to do? Hold on, what do we need to do? And find the distance to the middle or what? I forgot. How many steps does it take to get from the starting to the furthest? Yes. So in this case, our loop is going to be 1, 2, 3, 4, 5, 6, 7, 8, and then we just divide it by 2, right? So we just do loop positions, length divided by 2, and this is our answer. You know? Day 10, part 1. This should be part 1. Okay, the answer is 4. Then just run on the day 10 without the example. And this is the answer, 6697. For me, this is the right answer. All right. It felt like it took a little bit of time for me to write, even although this is actually very simple here. I'm not sure. I did not do the timer. Let's see the part 2 here. Part 2, they say, is harder, right? You quickly reach the furthest point on the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. To determine whether it's even more, how many tiles are contained within the loop. For example, okay, I see. So we just draw it and we calculate the area. All right. I see. The above loop does the 4 tiles, the I, this one, right? In fact, there doesn't even need to be a full tile path to the outside to count as outside of the loop. Squeezing between piles is also allowed. All right. Okay, so we just need to find the area. How many tiles are enclosed by the loop? All right, this is very simple. Hold on. This is very simple. I thought it was going to be a hard one. So here's the thing. When we want to basically calculate the area. We know the basically like the polygon kind of, right? We know the shape of the thing, of the loop, which is basically the polygon, and we want to find what is inside, what is the area inside. So the way you can do it is you can like every time you go to the right, basically, you can add the area to the very like bottom, for example, and then when you go left, you subtract the area to the bottom, and when you add all of those together, you get the area inside. So it should be very simple here. We know the loop already. We know the loop already. Let's start with the example just to check. So now that the answer is going to be loop positions. I mean, circular tuple windows. There you go. There's even a thing like that in the iter tools. I want to find not just the windows of the like two things, but I also want to go in a loop. The returns iterator of all the windows, wrapping back to the first element when the windows should otherwise exceed the length of the iterator. There you go. So it means that as the last element, we're going to connect the last point of the loop with the first one to like actually close it. All right. So I'm just going to map the thing. So let's see, we have position 1 and we have position 2, right? And we want to calculate something here for every edge, basically, and then calculate this sum of that. Whatever, we just use this this type to calculate everything. So like I said, what I'm doing is if position, if the edge is vertical, we're going to ignore it. Which means that if the column is the same, and we're going to ignore it, otherwise we are going to return, because now they are different. Now it means that the it is not vertical but actually horizontal, which means that the rows are going to be the same, right? The rows are the same, and we're just adding the area. Well, it depends, I guess. Let's see, what do we actually want? If we are going to the right, we want to add the number of tiles well, I guess it depends on if we're doing clockwise or counterclockwise. We could have found any one of those, but yeah. Why is there an emote for doing clockwise? For team on Team Bidet? Bidet? Alright, we're going horizontal. If this is more, because Team has problems with clockwise versus counterclockwise. But it's not even visible on this emote. The arrows are barely visible there. I don't think this emote like is very helpful. You need to make those arrows bigger. This emote is, yeah, this emote is actually counterclockwise. All right. Okay, if we are going to the right, then I'm going to add this. Well, okay, here's the idea. Here's the idea that I have. Like, you know, if we are going to the right, then we know this row index, right? And then we were going to the left, some when, like, in the future, right? We know this index. So the number of tiles that we need to calculate and add to the answer is the ones between them, right? Which means that the index when we go to the right, -1 minus the index when we went to the left, basically. You know? So if we were going to the right, then we're going to take the row index with the -1. Otherwise, we're going to subtract the row index. And that's going to add up properly eventually. Now, the only thing is we want to make sure that we are going proper direction here. Well, technically there's only 2 answers, you know? There's only 2 answers that we can get. So I mean, you know what? We can just run this, and if this is negative, we just flip the sign here. We just flip the sign like that, you know? And then we have the hold on, is this even the correct one? I'm running on the example. I think this is not the correct answer even. Oh, wait, hold on. I know what the problem is. Hold on. It's a little bit different, like, compared to when you calculate the polygon area. So what's happening is, we have this simple example of the pipe looking like this loop, right? And as you can see, I'm moving to the left 2 times over here, right? So like I'm calculating the area here, and I want to calculate instead this thing. How do I do that? Hold on. Is it only if we're going left and the next one is like also going left? Hold on. What would we need to calculate? If it was something like this instead. Right? We need to add these two. And to figure out what exactly am I calculating, because I like again the thing that's making me confused is that I'm used to calculating the area. So like I would calculate the area of 4 here easily, but because I need to calculate the number of tiles of points, that's a little different. So once again, if we go to the right and then we go to the left, right, then I can add the number of points in between, maybe. The number of points in between on the right side. Let's do this. We're calculating this thing. That's what we're actually adding. And the problem is when we are going on this side, when we're going along this thing, okay, so there is no going left here, and there is no other going right here. But there can only be things like this. Is it if we are going down, and we need to also subtract one? It seems wrong. Why am I not, like, counting the ups then? But I think that's the thing. So right now, what am I doing? If we are going to the right, then I add that. If I'm doing vertical, then I need to subtract one. In the case we're going in a specific direction. I'm not doing very good job for this task. I'm just like guessing right now. And also this is also wrong. Hold on, why is this? What am I calculating here? I want to calculate this one, right? So when we're going this right and then this left, we're going to add up this one. And then over here, we're also going to add this one. Okay, fine. Fine. Here's what we need to do. If we are on a position, right? And then we are not going my brain is broken today, I think. All right. Deagle, how to grow a beard? Asking for a friend. Hello there. Just don't shave, I guess. All right. Actually, that was wrong. You need to shave a lot and then at some point stop shaving. And thank you for the sub. Hold on. I feel like I know the solution, but I'm for some reason have trouble here. You know, shaving doesn't help the beard grow, right? That's a myth. Okay. Yeah, probably. You hear that? That's a myth. You are wrong. And to rub mustard on your face every morning and evening. Well, there you go. There's another advice for you, Digo. You can try that. That's probably not a myth. Rust makes the beard grow and C helps the hair fall off. It has been proven. Hold on. I'm trying to solve this thing here. Why is it so hard for me to understand what I need to do here? Actually, hold on. I know that there is a formula. Where if you have a basically like a polygon, and you know the number of points on the edge of it. So for this one, the number of points on the edge is 8, right? Because that's the length of our loop. And we know the area of it, which is 4, right? Then we can know the number of points inside. I think I remember a formula like that. Is that not called the Euler's formula? I mean, there's a lot of Euler's formulas, right? Area. Integer points. Integer point enumeration. Like this thing. Pick's theorem. Maybe this one? Hold on. Maybe it's the Pick's theorem. Provides a formula for the area of a simple polygon with integer vertex coordinates in terms of the number of integer points within it and on its boundary. Formula. Suppose that a polygon has integer coordinates for all of its vertices. Let I be the number of integer points interior to the polygon, and B is on its boundary. Then the area A is this, right? So let's say that we know the area and we know the points on the bounds, right? In order to calculate the number of points on the inside, we need to get the area, subtract the points on the boundary divided by 2. So the area is 4. We subtract from that 8 divided by 2, which is going to get us 0, and then we add 1 there. There you go. We can use this formula. For example, if I just calculate the area normally, you know? How did I even remember that this thing exists? I have no idea. But anyway, this is just going to make it a lot simpler. We just calculate the formula like I'm really used to already. If we are going horizontal, then it's 0. Otherwise, if we're going like one way, then we add the current like row with the plus sign. Otherwise, with the minus sign, you know. Just like that. If chain can be rewritten with a match. Can you rewrite it for me? I guess we match P1 compare P2. Right? Is this it? If it's less, then we do negative P1. If it's greater, then we do positive. Otherwise, we do 0. Just like that. This is how we calculate the area. You know? area is this. And then we take the absolute value of that. That's a wild formula. Do you not know about that formula? Isn't that taught in schools? I'm not sure where I know this formula from. I mean, let me make a link to this here. So answer is the number of points inside. It's going to be area minus the points on the boundary, which is the loop position's length, right? We divide that by 2, and then we add 1. All right, and that is our answer. There you go. There you go. Let's go. Day 10. All right, 4, 2, 3. Let's see if this is correct. This is the right answer. Would it be possible to do a more brute force thing? Just replace your path with X and then just count the stuff between? Yeah, I guess the brute force would be nice. You can like go from like bottom to the top and like maintain like a flag whether you are inside or outside, and like do it like that, I guess, instead. But I still think that I could have adapted the way I'm calculating the area. But I don't know, for some reason it seemed pretty hard for me to try. Maybe it's not possible. Like I need more information, not only about the current edge. Would a flood fill work? Did I finish part 2? Yes. I used the peak theorem. Do you know about this one? This is the theorem that I used. So a bunch of solutions. I'll calculate the area, I know, and based on the area, I know the formula. Shoelace formula? What is the shoelace formula? Also known as the Gauss area formula and surveyor's formula to determine the number of to determine the area of a simple polygon. I mean, the thing is, the area is not what you want to find, right? You don't want to find the area, you want to find the number of integer points inside. So I use the shoelace formula to calculate the area, yes, but then in order to calculate the number of actually points inside, I use the Pick's theorem. You can also do concave hull. Why? No. Why would you do concave hull? A parity solution. What's a parity solution? Or you count how many pipes you intersect? Even or odd means, yeah, that's like easier than the flood fill, I think. Because for the flood fill, you need to be able to like continue the flood fill from in between the pipes, which probably means that you like need to make your map like twice as big, so that like I mean it is pretty easy, I guess, yeah. How did people how did people convert this formula into calculating the number of integer points without using the Pix theorem, though, is what I'm wondering, because that's what I was trying to do for a long time, and I could not figure it out. It seems to me that you need more information than just about the current edge when you add something. Angle formula is the basis of the population formula, which is is the calculation of this by hand.
Now it takes 2 seconds. Wait. Can we...
My internet is okay.
Can we solve this by hand? Is that cheating?
Wait, you solved it by hand?
I think it is pretty countable.
That's cheating.
It would be faster than implementing it.
Wait, did you use the flood fill in Paint? And then calculate the number of pixels that you have
Oh my god, yes.
filled?
Alright.
What?
We're gaming.
Could you not have used Bash to call something like, I don't know, Image Magic or something? Can Image Magic like do the fill, the flat fill? So you could at least try to do that, not by hand, but in Bash. Oh, you did do that after you got the star? All right.
On the black.
Amazing. All right. What did you use? Fill black. Convert anti-alias. Convert. Convert is a program called Image Magic. Why is it called Convert then? Is it like the new name for the Image Magic? Has it been renamed? Oh, it's the old name. Now it's called Image Magic. Alright. Why are you using the old one? Alright. Good. Alright, before solving the next one, let's take a break. Where is Brainoid's game? Where's Brainoid's game? Super Pinball Master. That Brainoid did for the Pacifist Gem. Create pinball levels and play other levels. Oh wait, there's no web build. Why can you not make the web build? You did do this in Unity, right? What's wrong with the web build? Database connection? What's wrong with the database connection? You cannot do the connection to the database from a web page? They only give you the raw socket? Alright. Downloads. Pinball. What is it? What was it called again? Super Pinball. Pinball Maker. Username. Guest Plunger. Movie man, password. Don't steal my account, please. Sign up. Oh shit, I need to sign up first. Password is optional in case you want to play the game on another device later. Oh, I see. Alright. What is that error? Game broke the first second? Wait, there was an error? In the terminal? Where's the error? Unhandled feature 0xe. Check feature support. Something for DirectX. I don't know. I mean, it seems like it's working. Three-tier database often responds late. Sorry. It says oops on top. Oh, connection to the database is lost. Alright. Do we launch it again? Login failed. Don't know the reason. Connection to database lost. Alright, what if I add this to the Steam? Maybe it's going to work better. Connect to the DB somehow. I mean, I'm not sure. Can you try if it works for you right now? Maybe your database got broke or something? Is it working for you right now? Did my Steam just got crashed? Hold on. Adding your game to Steam crashed my Steam. Really? Login failed, don't know the reason. Connection to database is lost. Maybe it's because... Wait, hold on. Maybe it's because where you're hosting it and I cannot access it without like a VPN or something because because of where I am. That also might be the case. Might be not because of Linux. Where are you hosting it? All right. In OS Ireland. I mean, depends on the depends on what the like. They can still do it. I think. Some websites just do it because they want to. All right. I guess we're not playing the game then. Too much work. Set up the VPN right now to test it, or maybe it's not that issue. Maybe it still is a new Linux issue. I don't know. Oh my Jerome, were able to log in? All right. And I'm not rebooting into Windows to test it. Not right now, at least. I can check it later to let you know. Alright, let's do the next event of code then. Day 11. Cosmic expansion. You continue following signs for hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. He doesn't know anything about the missing machine parts. He's only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Maybe you can help him with the analysis to speed things up. The researcher has collected a bunch of data and compiled the data into a single giant image. The image includes empty space and galaxies. For example, this researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. However, there is a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. I mean, I can try, like, I don't know, like, go into the website and see if it's blocked for me, whatever you're using. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should all actually be twice as big. Alright. Equipped with this expanded universe, the shortest path with which every pair can be found. It can help us assign every galaxy a unique number. 36 pairs. Only count each pair once. And how do we calculate the distance? Using only steps that move up, down, left, or right. So this is the Manhattan distance that we need to find between every pair of galaxies. Okay. And then the sum of the lengths. All right. Sounds easy. Okay. So what are we going to do here? We're going to find the map. I'm not going to, like, actually get the expanded map. What I'm going to do instead is to find for every row, if there is or if there is not a galaxy on that row or in that column, right? Day 11, part 1. Can you do lead code? Please. Alright, can I do it after I solve day 11? Wait, hold on. How many days do we have left? Day 11 and then 12 and 13 that I need to do. He has the database on his local machine, but cannot access to documentation in the website. Yeah. Okay, day 11. We're going to read the map. So this is the compressed map, right? I mean, let me just get the galaxy positions, you know. Read to string, input day 11 example. I'm going to take the lines here, enumerate. This is the line index. Flat map for every line index and the line. We are going to do line characters. Enumerate. Filter map. So we have the column, and we have the character itself. And if character is equal to the hashtag, then it's a galaxy. So then I'm going to do line index and column, right? This is our galaxies basically. In the form of their positions, because that's all I need. All right. So now that we have the galaxies in the form of just a list of their positions, right? I need to let's see. I'm actually wondering, can do it better here. Let's see. I want to do a binary tree set of the all of the different rows and all the different columns of the galaxies, right? So rows is going to be a hash set. No, not hash set. Binary tree set of all the different rows that we have. And this is going to be galaxies. Iterate map. Row and column. We just take the row from it, right? And then similarly, we're going to calculate all the different columns. We're going to take the column instead, right? And then we're just going to calculate for every pair for... Let's see, is there something to iterate over the pairs in itertools? There probably is, right? Iterate pairs, no? Itertools. Cartesian product. No, combinations. I think combinations is what I want. Returns an iterator adapter that iterates over k-length combinations of the element from the iterator. The element type is going to be the vec of self item. Can I do combinations of two basically, which are like tuples instead? Tuple combinations. There you go. That's easy. There you go. We have the first the first galaxy and the second galaxy in galaxies tuple combinations. Kuvi, can you move in with me? We can do push-ups together. Huh? Pigorly push-ups post-champ. Alright, let's see it. Let's see it, Pigorly. Show me how good you are at doing push-ups. And I will think about it. To avoid the sanctions? I mean, you probably cannot, like... I mean... If you... Wait, hold on. What do you mean by avoiding the sanctions? I guess it's because, like, you're not using their database in the way that it is supposed to be used. It's not supposed to be used from a game. By everyone, right? You're supposed to be the one who actually has the access to it. And they don't want to sell their services, basically, to avoid the sanctions. So, like, yeah. Alright, anyway, we have A and B. Here, we have tuple combinations, right? That's how we iterate over all the pairs of galaxies. And now we just want to find the distance between these two galaxies. So, like, distance, like the row distance, it's going to be the distance on the rows from A to B. And then the column distance, going to be distance the columns from A to B. And then we add to the answer the distance, row, which is going to be equal row distance plus column distance, basically. So how do we calculate the distance along one axis, basically? Distance. So, like... so this is position A, position B, but we also want the galaxy positions. Like, we only count that axis, right? Each reset. Okay. So here's what we're going to do. First, like, one of the things that we could do is we could just, like, iterate over. And I think it might be working for this problem. But I think we can do it easier here, because the binary tree set has a thing which is called the range. So we construct a double-ended iterator over a subrange of elements in the set, right? So all I want is to calculate the amount of galaxy, the amount of basically like rows or columns in between A and B. Is there a function somewhere that's called min-max? Am I the only one who making those? I just want to let's see this. If A is equal to B, then we're just going to return 0 here. Otherwise, the range that I'm going to need is the minimum of A and B plus 1 until the maximum of A and B. Right? So because I want to exclude the minimum and exclude the maximum here. There is min-max? Why can I not never find it? Min-max? It's nightly. Yeah, it's nightly. I guess. It's good that they're adding it at least. I'm just really used to, because we have it in our Batbox library. Okay, anyway, we do from minimum to the maximum, we find the range, and this range we probably can't find. Yeah, if I get the range, I can just get the length of it, right? Can I not get the length of it? On the binary tree, it's not calculated, I guess. Okay, well, one of the things that we could do is have the rows and columns in the form of... Okay, sure. Let's do it... Sure, let's do it differently. Let's do it differently. Here, then. Let's do it differently. Axis, positions. Like this. I'm going to store them in a vec instead. In a vec. So I'm going to do galaxies, iterate, and then map using the F, and then collect into a vec. Of things, right? Then I'm going to sort, and then I'm going to dedupe like this, which is almost the same thing as a binary tree set, I guess. Okay, so rows is the sorted list of different rows that the galaxies are in, and columns are like similarly just the columns. All right. But then this cannot be the closure. Because those closures have different types. All right, amazing. Let's make this a function then. So this is going to be implementing function from reference to that, returning that, right? And the galaxies is going to be a slice. And this returns vec of positions. So now I'm just going to get the galaxies as an argument here. It would be really nice if I could make like generic closures, which can take generic arguments like this. Because, yeah. So galaxy positions is going to be just like that, right? And I'm just... all I need to do is to calculate the number of empty positions in between, you know? number of empty positions in between is what I want. Which is going to be b minus a minus 1 minus galaxy positions between, you know? So galaxy positions between is going to be the galaxy positions. I'm going to do the binary search here. Using the minimum plus 1, right? This is going to be... Can I do something like unwrap or map error? Is there a thing like that in Rust? Because the binary search returns a result in case of an exact match, or where would we insert it? Have you had glib cnet found error? No. Maybe, I don't remember. So what I want here is to get a result and get and unwrap it. But in case it's an error, I want to map. I can do a match here, I mean. But I will want to do it twice, I guess. Okay, value. Okay. If it's okay index, then index. If it's error index, that it's also going to be index. That's what I want here for my binary search. So this is the first position that is basically more than the minimum. All right. And then I want to find the first position that's more than or equal than the maximum. So I'm going to over here. I'm going to subtract that from another binary search where we just search for the maximum. Okay. Just like that. So like the thing that I don't like here is that we like copy paste the match here. In C++, it's called upper bound. We can do upper bound. Upper bound, like in C++. For X is going to be match galaxy positions, binary search, X. Okay. Index, index, index. It's not the upper bound. Hold on. It's the lower bound. Yeah, so we basically do lower bound for the maximum, and we subtract the lower bound for minimum plus 1. There you go. And this is the number of galaxies in between. Now the empty positions in between. And then the distance is actually going to be the distance, right? I mean, this is maximum minus minimum. The actual distance is going to be maximum minus minimum, but also we are going to add the empty positions in between because those are going to be twiced. All right. Day 11. Okay, I got 349. Is that even the correct thing? No, the actual answer is 374. Okay. Well, let me see. A to B is equal to distance, O distance, slash column distance. Let's see what is wrong here. So we have the 0, 3, so this one, and we calculate the distance to 1, 7, which is this one. Hold on, why is it 0, 3? Oh no, 0, 3 is this one, yeah. And then 1, 7 is the next one. So like from 1 to 2 is what we calculate here. And the distance is 5. Because we have 1, 2, 3, 4, 5. I mean, it's at least 6. Hold on, what's wrong here? Something is definitely wrong in my function here. We get the maximum minus minimum. And then we add the empty positions in between. Between the distance between 1 and 2. This is already the expanded map, right? Yeah, this is already the expanded map, so the distance between them should be equal to 6, right? The distance between this is this, yes, and over here it should be 5. But instead it's 4. This is the distance on the columns. All right. So let's see. On this map actually. On this map the distance is 5. But the thing is, the number of empty columns when we go is going to be equal to 1. So I did not calculate the number of empty columns properly here, it seems. Let's do a little more debugging here. So when we calculate from 3 to the 7, the number of empty ones is 0, which is definitely wrong. Right? Let's do the galaxy positions. Because the galaxy positions are 0, 1, 2, 4, 5, 6. Wait, what? Hold on. The galaxy positions are incorrect. Are they? I'm going from 3 to 7. But why is 3 not here? Because that's where I'm going from. And then the 7 is also not here. Wait, what? Am I calculating the galaxies incorrectly? I'm calculating these ones, yeah. It's row here and it's row here. All right, I found the bug. For the columns, we need to get the columns. I copy pasted and did not replace it properly. Okay, the answer is 374. It is, all right. Found the bug. It was a stupid bug. Now we can run on the actual input. This is our answer. Let's continue to the part 2. The galaxies are much older and thus much farther apart than researcher initially estimated. Now, instead of the expansion you did before, make each empty row or column 1 million times larger. There you go. It should be very easy. And that's all we do. We just multiply the empty ones by 1 million, right? So all we need to do for the part 2 is we multiply the empty positions between, not by 1, but this minus 1, because that's how many I add. All right, let's run this on the example first, just to check that we want the correct number. Do they not provide me with the answer for the example? In the example above, is M shrub were merely 10 times larger, then it would be this. Okay, okay, fine, let's do it to 10 first. The sum of the shortest path between each galaxy would be 1030. Yes. If it was 100 times larger, then it would be 8410. Alright. And then we finally do replace it with this thing. And run on the actual input. And that's the actual answer. Right. That was very easy. Day 11 has been solved. And we have 2 more to go. Day 12, hot springs. You finally reached the hot springs. Oh, we're lead coding now? Oh, you want me to lead code. All right. Sure, let's do a little bit of a lead code. This is a medium one. Medium lead code. Find the duplicate number given an array of integers containing n+1 integers, where each integer is in the range 1n inclusive. There is only one repeated number. Return this repeated number. You must solve this without modifying and use only constant extra space. So the n that we get is the length minus 1, right? Correct? Correct. So if you add all the numbers from 1 to n, then like then you are going to get, so like the arithmetic progression. Read the constraints. And is this? The integers appear exactly once, exact precisely one integer. Yeah, I know. Oh, which appears 2 or more times. What do you mean 2 or more? It will be exactly 2, right? One, 2 to 2 is valid. But then... Oh, I see it. Alright. Okay, fine. The solution is trying to work. Okay, okay. Well, I will iterate over what n is basically then, right? Well, hold on. We need to use constant extra space. Okay. So if we know what is the n. Hold on, wait, what? Are you sure that 1, 2 to 2 is valid? Not every... so like in case of 1, 2 to 2, what is n? N is 2 then? But then it means that the length is not correct. 2 to 2 is also valid. All integers in the numbers appear only once except for precisely one integer, which appears 2 or more times. Oh, not every number from 1 to n is appearing exactly once. Okay. I see. we do not modify the array, which means that we cannot sort it, right? And we want linear runtime complexity. It's confusingly written, yeah. I think it's confusingly written here, but okay. I understand now. There's only one repeated numbers. Well, you can, like, this is the follow-up, right? If you don't do the follow-up, then the stupid approach is to just to do the quadratic solution, where you see and you find the number which appears multiple times by iterating over all the indices and seeing if it's also like appearing somewhere else, right? But we want the linear runtime, right? Yeah, only interesting with the follow-up. True. So it's not even the arithmetic progression, right? It can be it can also be something like 2 2 2 2 2 with a 3 in the middle, right? That is, and it is not sorted, yeah. True. It is not sorted. So it's not the maximum number that's going to be repeated multiple times. It's just the minimum number. It's whatever. Number. It's any number. All right. Let me think about it for a second. Yeah. Oh, there's it's actually is in the examples, you know? It actually is in the examples. There is this one. Ah, no. That is still 1 2 3 4 with 2 3s. Hmm. Let me know if you need a hint. Did you use a hint? Well, I can still like try iterating over like the number of times it, like if I know the number of times, then can I solve it in like constant amount of time somehow? Well, every other number exists only once. In case our number is appearing twice, then we are going to have the arithmetic regression for sure, right? If it's like if it's repeated 3 times, then it is one of the numbers removed. Then it is one of the numbers removed. Hold on. So, and the number we're removing is can be any number from 1 to n. So it's the sum of the arithmetic progression minus 1 or minus n, and that's like the valid range. And these ranges are actually non-intersecting. But the problem is if the repeated number is repeating 4 times, right? Then it means that it can be anywhere from the arithmetic progression minus 3 to arithmetic progression minus like almost 2n. And that is actually intersecting. So like based on just the sum, would even match the arithmetic regression. Wait, what? The input? The input cannot, because there is only one repeated number. What do you mean it could match? No. So what I'm saying is that if you have numbers from 1 to n, right? Then if you just add those numbers together, then it is a specific thing, right? If you from this sum are going to remove an element, then depending on the element, it's going to be either the sum of the arithmetic progression minus 1 or minus n, depending. So like that's like the segment of valid sums. And if you remove 2 numbers from the list of numbers from 1 to n, then it can be anything from this to somewhere over there, you know? So, yeah. I don't think we can do anything based on the sum of the numbers here. I don't think we can do anything based on the sum of the numbers. Maybe we can do something based on the product, though. But the product is very big number, is the problem. Like based on the I don't know. How many prime numbers, for example, are there from 1 to 10 to 5? There is still a lot of prime numbers, and that would not be a constant extra space, right? Ilya from space, hello. Yeah, Metensis, you probably don't understand the one of the, so like in these examples, the number 2 appears twice, the number 3 appears twice, but it can appear more, and then in that case, yeah, there's like that sample where like all the numbers are the same, for example. I'm not even sure. Like, let's there can be a sample where you have like, you know, 2 2 2 2 2 2 2, and you have like n, right? Or it can be 2 2 2 2 2 2 2 2 and 1, right? So how do you know that? Only one repeated. Yes, only one repeated, but it does not say how many times it repeats. So it can repeat a lot of times. So how do you know about this versus this? We want to use constant extra space and we want to do linear runtime complexity. Greetings, brutes. Hello, hello. This problem is cursed. Why lead code problems? I don't know, because Arya wanted to see if I can solve this one, and it seems like I cannot. I don't know. Are we willing to wait for me for an hour? Because maybe I will come up with a solution, but I don't know. Maybe we can do a hint. In terms of problem category, alright. Sure. It's a linked list problem. A great set. You don't know what's linear type complexity? Which means that... It means that you need to, like... I don't know how to explain what is time complexity and what is linear time complexity. You don't want to iterate over all the pairs, for example. Linked lists are not easy in Rust, right? And linked lists are okay. You just don't need it. Usually, there are a lot of ways to do the linked lists. A linked list. I mean, I was trying to think somewhere in that direction, but then what? You have a linked list of what? You program in Unreal, so usually don't bother. Yeah, for the most of things, you don't need to bother about the complexity and what it is. I agree. But Unreal makes you making games, so like for some things, you do want your code to be running fast, right? And then you might want to know what it is, what it means. Like if you are making a game where you have 1,000, like 10,000 entities, for example, and you want to do something with each pair of those, it's going to run not very quickly. And like sometimes you can solve this by introducing like a data structure which can filter those pairs that you need, which are like close by, for example, for physics. Anyway, can you send the link to this one in chat? Yeah, sure. Another hint? Let's do another hint, sure. Cycle detection. Does LeetCode support a lot of languages? These are the languages that they support: C++, Java, Python, Python 3, C, C#, JavaScript, TypeScript, PHP, Swift, Kotlin, Dart, Go, Ruby, Scala, Rust, Racket, Erlang, Elixir. Not all of them. And it also depends on the problem. Some problems can only be solved in a specific set of languages. You think you get it? Not a lot. Well, less than like Codeforces, for example, yeah. No schema closure, yeah. No D language, no NIM, no Zig. No GDScript. Find maximum element in a sorted array is a linear complexity, so we can use the for loop. Yeah, but we don't need to find the maximum element. That's the problem. It's not always the maximum. This is definitely not a medium problem. I don't know. Like sometimes, like when you solve things, you can think for like an hour on an easy one, and the hard one is the thing that you can solve in like 5 minutes. I don't know. I need to know the solution here in order to tell you what the difficulty actually is. Sometimes you just need to think in a specific direction, and your brain tries to think about different things instead. Am I allowed to use libraries? Pretty sure that you don't allowed to use libraries here. I'm not sure. I mean, there is some specific set of libraries that they probably have included in the compilation, or maybe it's even no libraries at all. I haven't thought about parts of the actual solution, but couldn't figure it out. At least it is the standard library available. Yeah. They just do the Rust C your file.rs, I think, over here. You can just put the numbers in a hash and return the number. No, you cannot, because we need to use constant extra space, and a hash map would use linear extra space. That's the easy thing to do, obviously, yes, but we need to do constant extra space and linear runtime complexity. Without any of those, it's easy. Yeah, sorting hash mapping is trivial. You also need to not modify the array itself. If you could modify, that's just sorting, but sorting would not be linear like anyway. What's the linked list here? It's the linked list here. I don't know, the next of the same number, for example, is what I'm thinking about in terms of linked listing. So only those numbers that are actually repeated multiple times would be linked with each other. That doesn't help with anything though. Think of the 1, 3, 4, 2, 2 example. What's a linked list? I have no idea. What do you mean a linked list? Maybe because I am using Rust and I'm not working with linked lists. Like my brain just doesn't work by like in terms of linking any lists. I cannot do that. Solve it in C# instead. All right. 1. I mean, I would say that you could try like linking to the next to like from x to x plus 1. That doesn't help with anything. No idea. Use array indices. For the linked list. I think I surrender. This one is 1 points on index 1. Yeah, but now what? You're not limited to linear time solutions, right? I mean, we are, because that's the follow-up. Without the linear, it is also easy. Like, the quadratic solution with constant extra space is easy. Three points on index 3. Okay, I see. I see what you mean. I see what you mean. Hold on. 1 to 1. I see. So you want basically... Okay, okay. I see it. So we have numbers from 1 to n, right? Which are there exactly once. So if we try to... If the number 1 right now is not on the first place, then we're going to like basically put it on the first place in our mind, not actually by modifying the array, right? But we're going to put it on the place 1, and then we see what is in the place 1 right now, right? If it is something else, then we need to put it somewhere else, right? And just like that, we are going to... Well, we can go in a loop though, can we not? I mean, I know that we cannot modify the array. I'm just saying, like, in our mind. Yeah, you can. Okay, you find the loop, but the problem is you need extra space to figure out if you have already been in the position or not. Oh wait, hold on. But nothing needs to go on the place n+1, right? So that's so for that reason, the last whatever is in the last position is not going to loop on itself. All right, I think I see the solution here, Arya. Yeah, all right. Yeah, that's funny. I don't think that's very... I mean, the solution itself is... Yeah. So we try to basically place the number that's the last one, which is basically n+1, which should not be in the array. Even from here, it's kind of tough. So we try to like, if it's whatever number, then we like go somewhere, and then we go somewhere else, and then eventually we're going to loop, but we're never going to loop in the last position, basically, you know? We're going to loop in the same position twice, which means that this is the thing that has been there multiple times. All right, I'm not sure if I explained myself well, but here's what we're going to do. Here's what we're going to do. Wait, hold on. But you are right. We still, like, how do I even know if I have been somewhere or not? Because we need to use extra space for it, right? How do you know which one is the duplicate? Well, the one that is the duplicate is the one when we are actually like entering the loop, you know? Again, how do you find entering the loop? Well, that's the question, right? Because right now I only know how to do it with extra space by storing a boolean for everything. Another thing is once you enter the loop, if you go, well, basically what I'm saying is that if you do n turns on the linked list like that, then you are going to be inside the loop for sure. Does it help us with anything? There's a named algorithm for this, actually. I might actually remember something similar to this. Yeah. But the question is, how long can our loop be? Wait, hold on. I just no. Like, I can calculate the length of the loop. I can calculate the length of the loop by making sure that I'm inside the loop by doing n turns, and then basically going on again until I like get to the same position by saving that one position when I'm inside the loop. So now that I know the length of the loop, if I know the length of the loop, then oh, I see it. Hold on, I know. So we do something like this. So we basically are going to follow the things like that, right? Eventually we are going to go into a loop, right? In order to calculate the length of the loop, we are going to do like n steps to guarantee that we're inside the loop, find the thing that we're at, and continue following until we go back. Now we know the length of the loop, right? And now in order to calculate the position where we enter the loop, we are going to do 2 iterators, basically. We are going to start from the beginning again, but we are going to do exactly the length of the loop steps forward, and then we're going to move these 2 like iterators at the same time, and we're going to do that until we hit the same node, basically. All right. What's this thing called? I remember something like that. It's not very common, but I do remember something like that. Floyd's algorithm, is it? No. Floyd is for calculating the distances, but maybe that's another one. Floyd algorithm. It's not Floyd-Warshall, I guess. Some other Floyd algorithm. And we're not calculating the shortest. That's it? No, that's for calculating the shortest paths. Which is like different, no? You learned how to find the cycle in constant space? I don't know. Do you want to think about it more? Floyd cycle detection algorithm. Yeah. Floyd cycle detection. So this is for the basically for any directed graph is what, right? Single directed. It's not the linked lists. These things. It's just a graph with one unbound, like, outgoing edge from every vertex. Floyd cycle detection. I don't think I ever used that. I definitely don't remember naming it like this, at least. The messed up link list. I don't think anyone can solve this in an interview setting if they didn't already know it. I remember something similar to this. You definitely can solve it, but for some of the problems you need more time than just. I mean, not during the interview, I guess. Maybe, I don't know. It depends. It's been a long time since I was doing a lot of like competitive programming, but not a lot of, like, most of the people will not come up with this. I guess that's true. So it's not the medium one for sure. I think. Just invent the algorithm. I mean, I invented the algorithm at some point where Arya said that I should point the number 1 to index 1, right? And then at that point, it was pretty obvious. Like, you need to think about that, though. And, like, I'm trying to think, have I ever done this before? I definitely did, pointing the number to its index. And constructing a graph like this, yeah. Okay, we calculate the loop length, which is going to be... I had the idea to have multiple values points to indices, and then I saw there's a loop. Slow fast pointer. Okay, so this is our graph. From one vertex, we can go from one thing, we can go to its to over there. Yeah, okay. So we start with n. And then we do for n times, because then we are going to be guaranteed to be in a loop. We just do v equal to go v, right? So now we are guaranteed to be in the loop. So now we just do like, I don't know, x is v. So we do while v, I guess we do loop v is equal to go v, and if v is equal to x again, then we're going to break the loop, basically. Loop. So that's like the length of the loop that we have calculated here. Another key part is that nothing will ever point to index 0. Well, or I'm starting from the last one because I'm subtracting 1 here. But you can also do it from index 0 instead, I guess. I guess that's actually even easier. We just do this instead. And we start with 0 instead of starting with n. That's the thing. It's the same thing though. You used ChatGPT? Easy. Did ChatGPT solve this one? I mean, that's probably a known thing anyway, right? The Floyd's algorithm is known. So ChatGPT should probably know about it anyway. Okay, so we just literally do while v is not equal to the next. We do v is go v and next is go next. Like this. Then we're finally inside the loop. Which is basically like the index, right? And that's what we like actually return. Is that the entire thing? Can assign twice. This is mutable. And this is mutable. Language doesn't even matter here, it's just arrays. I mean, yeah, language doesn't matter. I agree. Alright, there you go. So we do 1 loop, 2 loop, and 3 loop. So it's maximum of 3. Beats 12% of users with Rust. Huh? Can you do this faster somehow? Like, you don't know how to prove this O(n) though? Wait, what do you mean? Because the length of the loop is never going to be more than n. So the loop length is O(n). You know? And then this loop is O(n) because you're going to do the maximum of n operations here too in order to get into the loop. Right? So we have 1n, 2n, 3n, 4n. 6 ms for you. Is it because I used closure? Is it because I used usize here? I mean, we just use i32. Maybe i32 is faster than usize because this is 8 bytes and this is 4 bytes. Sometimes that can be the case. We just do this instead like that. Is that faster? I mean, it's RNG actually. Like 15 milliseconds versus 2 milliseconds usually is RNG. Anyway. But not for me, it seems. We can also do get unchecked here. At this index. I'm pretty sure That is not going to matter though. Pretty sure this one is not going to matter. Show us your code. Now I have 12 milliseconds because I removed the bound checking. Is it because this closure is actually a function call? Like, can I make this one actually inline? Like, can I guarantee the inlining of this one, of this closure, for example? Because I'm not sure if it compiles to a function call or it's been inlined. It should though, right? Well, your code is actually shorter, which means that what's wrong with the formatting here? Wait, so tortoise is the one that travels at speed of 1 and hare is the one that travels at the speed of 2. And then eventually they become equal and we break. What? That's different. So we do 2 iterators. One of them is travels at the speed of 1 and another one is travels at the speed of 2. And then eventually they become equal. And then we go from 0 and from the slow one. That's Floyd, so my algorithm is actually different. That's what I did is not Floyd's algorithm then, right? So the last part is the same, right? So the tortoise is what? That's the thing in the because we're going twice. Oh, wait. So because you're going twice, this thing is going to be like hold on. I'm trying to understand this because like I'm finding the loop length exactly, but you don't need to have the exactly loop length. You want it is enough to have anything that is like divisible by the loop length, right? You invented a new algorithm, write a paper. Yeah, my algorithm is more obvious, I think. But this one is faster because I do like 4 loops and this one does 2 loops instead. Can I draw mine? Hold on, I'm trying to understand this one. I mean, mine is I've been explaining this, right? I'm finding the length of the loop by first making sure that I'm inside the loop by doing n steps, exactly n steps. I'm doing exactly n steps. I'm somewhere inside the loop, somewhere. Then I'm doing the steps until I go back to the same position to find the length of the loop. And then I do 2 iterators. One is in front of the first by the length of the loop. But you don't need exactly the length of the loop. You can do anything that's a multiplier of that. And that's what you get by doing 2 steps at a turn. Because So yeah, so you have been looped. Like the thing is like the question here is how can we guarantee that we are going to eventually be equal here? Like we are never going to like we going around each other. So like that's the question. That there are faster solutions too. Well, you are still doing the indexing here. You can do unchecked here and then it's going to be faster, I guess. Like I did get rid of like 3 milliseconds from my solution by doing unchecked indexing. So let's say that you are inside the loop. One of them is going 1 by 1 and another one is going by 2. Well, it means that their relative speed is 1, right? And that means that it like if you calculate just the relative speed of the hare compared to the tortoise, whatever they call it here, right? Then it makes sense that they eventually are going to meet, you know, because the relative speed is 1. It's pretty obvious. Yeah. And because of the way you do it here, the tortoise basically is going to be at a position which is a multiplier. Wait, hold on. The position is going to be the thing that I don't understand how to prove is why is the tortoise the multiplier of the length of the loop here, I think. At most 10 steps, yeah. So this one is at most 10 steps. So this one is actually a faster way to calculate the length of the loop. It's not exactly the length of the loop, though, that we're getting here, right? Or is it exactly it? Just says there's a loop because they met. Well, it's not... Well, how many steps did we do in this loop, though, is the question. And the number of steps, you think it has to be the same number as nums 0 and modulo loop length? Well, yeah, something like that. The number of steps should be divisible by the loop length, or be exactly that. You mean tortoise after the first part? Yes. The tortoise after the first part is so like this remaining part is exactly the same as in my code where I have calculated the loop length. So this is the next. The next after all of this code is the tortoise in their code because this is the same. Except for they start not from 0, but from nums from 0. So they do the first step immediately. But that still is like the same. The distance between the intersection point and the loop entrance point is the same distance. The distance between the intersection point. The distance between intersection point and loop entrance point is the same distance as from the start of the list to the entrance of the loop. The distance between intersection point and loop entrance point is the same distance as from the start of the list to the entrance of the loop. That, like, hold on, why can that be so though? Because if you have a graph which has a very long distance to entering the loop, and then the loop is actually a loop like this, right? Then the distance between the intersection point and loop entrance point is equal to 0. And this is not 0. 900 hours wasted, says Davey. Oh, wait. That's by watching my streams. Alright. Okay, whatever. You know, I solved the problem. It's okay. It's okay. We can do a little more theory. We know what the thing is. On the wiki page, they probably explain why and everything. Let's do the advent of code more. We have 2 more days to solve. Day 12 is going to be hot springs. You finally reach the hot springs. You can see steam rising from secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Sorry, common mistake. This is actually the onsen. The hot springs are next door. You look in the direction the researcher is pointing and suddenly notice the massive metal helixes towering overhead this way. It only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry, we are not very hot right now. We are playing a lava shortage at the moment. You ask about the missing machine parts for Desert Island. Oh, all the Gear Island is currently offline. Nothing is being manufactured at the moment. Not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they're hot. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one springy enough to launch you up there. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would even be safe to use. Worse yet, their condition records of which springs are damaged. Your puzzle input are also damaged. You will need to help them repair the damaged records. In the giant field just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it's operational or damaged. This is the part of the condition records that itself is damaged. For some springs, it is simply unknown whether the spring is operational or damaged. You gotta sleep. Good night. Good night, Arya. However, the engineer that produced the condition records also duplicated some of this information in a different format. Can I mute Discord? How do you mute Discord? I'm supposed to be in the streamer mode, which is not being detected lately for me. Do not disturb. You will not receive any desktop notifications. There you go. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. This list always accounts for every damaged spring, and each number is the entire size of the contiguous group. That is, groups are always separated by at least one operational spring. This always equals to 4, never to 2. Okay, so we have the map, and after every row, we have the list of consecutive things. So this is not damaged, right? However, the condition records are partially damaged. Some of the springs condition are actually unknown, question mark. Yeah, so we can like replace those question marks so that this is still the correct thing. Equipped with this information, it is your job to figure out how many different arrangements of the operation and broken springs fit the given criteria in each row. And the first line, there is exactly one separate group of 1, 1, and 3. Yeah, sure, because we can only do one here and one here. The second line is more interesting. Could be a total of 4 different arrangements. The last question mark must always be broken. Yes, sure. And each of these must hide exactly one. So there's like one of these two is broken and one of these two is broken. All right, makes sense. And then what we do, and then we sum of those counts. Okay. So we need to solve the problem separately for every row to calculate the number of ways to do the thing, right? So we do this by doing the dynamic programming here, I guess. And this example, we have 21. Day 12 example. Day 12. Day 12. Part 1. Okay, we read the input first. Right. For line in day 12 example. Wait, there is no such thing as lines here. I'm not going to do that then. For line in, just going to reach a string. Okay, so for line in line, the answer is going to be the sum. Start with 0. And we're going to add the answer for the current line. So for the current line, we want to find the map. And then we have, after a space, so we have a map and groups, I guess. It's going to be line split once using space. And then groups is going to be a list of counts, which is going to be groups split using the comma. Right? So now we have the map. Let's convert the map into a vec of bool of like how do I call these things? I mean state, spring state, I guess. Map characters, map. So we're going to have enum state for every spring. It's either broken, working, or unknown, right? That's the thing that we have. So hashtag is broken, dot is working, right? And question mark is unknown. Otherwise, we should not have any. Otherwise, it should not be possible. This is our map, and this is our groups of broken ones, right? It's not working, it's operational. What plugin is this sparkling things when you write? It's called the power mode. This thing. So now I have the map, I have the input. Now I need to solve for this input, calculate the number of ways. Let me think. Right now, my idea is to do the dynamic programming, but is it there's probably like an easier solution that we can do. Let's check our puzzle input. Our thing is not that big, which means that can we just do 2 to the power of that, you know? Let's see, solve for line. So answer is going to be line answers, and then answer is line answers sum, right? But before that, I want to like see what is the maximum length, you know, the maximum length of the input of the map. Line answers maximum. Mm-hmm. This has panicked. Because hold on, there can be no thing after the space here, or did I copy the wrong example? Why is this only 3 to 1 here? This shows the valid arrangements. This is the actual input. Or is this the actual input? Where's the actual example? I think this is the actual example, right? Okay, so over here, the maximum length of the map is 19, and then in the actual input is 20. Okay, so because the size of the map is not that big, we can just iterate over all the possible things, which is 2 to the power of 20. It's not going to be that long, right? And that's like the easy solution without using dynamic programming, I guess. But let's do a better one anyway, instead of doing that thing. So the dynamic programming is going to be, I'm going to solve for the part of the map for the suffix, for each suffix of the map, for every remaining part of the group. And how many do we have in the current group that we're building, I think. So here's what I'm going to do. I'm going to do solve, starting at position 0. Starting at position 0, starting to build the group 0. And the current group size is 0. So that's the thing. I'm just going to do it recursively, and then we add memoization on top of that, and should be good. The only thing is this is the data. Let's have this in the struct data. So map is vec state, and groups is vec size of groups. So we do data is data, where map is this, and groups is this. So now that we have the data, we do data.solve instead. I'm just going to have a method here. Solve. So for the map position, for the group position, and current group size. And this is going to return the number of ways. Okay, so here's what we're going to do. First of all, if map position is equal to the map length, then it means that basically we have done everything. And if group position is equal to the group self group's length, then the number of ways is 1, otherwise it's 0. So like basically this is a good ending, this is a bad ending. The current group size though, we should always finish the current group size. And I think in order to make that easier, I'm just going to make sure, because in our groups we only store the operational ones, right? Here's what I'm going to do. I'm going to add one more operational thing in the end, just so that I don't need to make it a special case there, so that when I'm in the end, my current group size is always going to be equal to 0. Assert that current group size is 0, basically. So there you go. This is something that we return in case we have done, in case we're done with the map. In case we're not done with the map, we're going to see what do we have in the current map position. So I'm going to match self map at the map position, and if it is broken, then we're going to continue the current group size. So I'm going to do current group size plus equal 1. You know, if it's unknown, then I'm going to close the current group. And if if it's operational, then I'm going to close the current group. Otherwise, we're going to do 2 of the possible things, which is either make this one operational or broken, right? I guess we can do something like for broken in false and true. We can only do that if we can do it. So like the current answer is 0, but if we can make the current thing broken to be equal false or true, so I'm going to match broken and self map at the map position. So like we can only make true happen if we are in unknown or broken state. I guess I can do the matches then. So this thing should be matching. In case of true, it should be unknown or broken. And in case of false, it should be unknown or operational. Okay. And is this. So if we cannot do that, then we just ignore it. Let's just do if we don't matches, then we ignore. So now we are making the kind of thing broken or not broken based on what we're iterating here. So we do if broken, then we continue the current group, otherwise we close the current group. So if broken, we're going to continue the current group. So we do current group size plus 1. So this is going to be the new group size after we continue in the current one, right? And we're going to add to the current number of ways solving for the next map position. The group is still going to be the same, and the new group size is this. Just inline that. Okay, otherwise if it is not broken, then I need to close the current group. So I say if so the group that we have completed group is if current group size is 0, is not 0, it means that we did make a non-empty group, right? So in this case we have made a group of size current group size, otherwise it's none. And the group that we needed to build was self groups get at the group position, right? So if they are equal, if we have actually built the group that we needed to build, then we can continue building further. And the map position +1, we can continue building the next group. I guess over here I can do plus the completed group is some. Convert that to an integer because we're not going to advance the group if it was nothing. And we basically start a new group at size 0. And that's it. This is the number of ways to like solve on the subtask, starting from map position, starting from this group, and if we currently have the group size specified there. So this should already work. Actually, we don't even need to make the memoization. So the memoization is only going to make this work like much faster. But according to the constraints that we have, like the size of the map is just 20, we should be able to just have it working quickly. So I have calculated the 149 as my answer, which is definitely not true. Definitely not true. Okay. Let's inspect, I guess. For every line, what did we have? Oh, that's oh wait, hold on. That's the answer for our actual input. So maybe that is correct. I just need to check this on the example. Okay, on the example is definitely not right because I only found one way to do the first one and then 0 ways to do everything else, which is definitely not correct. Definitely not correct. Because for the second one, it should be 4 ways. For the first one, it's 1 way, yes. Okay, so what is wrong here? If we are at the end of the map, then the current group size is 0. And if we have done all the groups, then it's okay. Otherwise, it's not okay. Okay, and then we calculate the number of ways. We try. Maybe this is incorrect. So we should be matching. In case we want the thing to be broken, then it should be either unknown or broken. In case it's not broken, that should be either operational or unknown. Okay. So if it's broken, then we add to the number of ways the remaining part by increasing the current group size by 1, which is either going to start a new group or continue the existing one. Otherwise, if it's not broken, then we have completed the group. If it's current, group size is not 0, then we have completed this group. And we needed to complete this thing. And if we did it properly, then we can advance to the next map position. And we don't have a group anymore. I don't know, it looks correct to me. I can try printing it out more detailed. I'm adding the operational in the end, yes. Captain Coder, thank you for the raid. Hello there, how are you doing? You were doing the Advent of Code, I'm assuming? I'm currently solving day 12, part 1 for now. Because I have skipped. So today we started with day 9. And we solved day 9 and day 10 and day 11. Now we're on day 12. I have implemented something that I think is the correct solution, but it doesn't work. We've been doing Advent of Code on stream this month. Nice. Yeah, I was doing the Bevy Gem, and now I'm getting back to the Advent of Code. 12 was hard, 13 was very doable. I think I will solve them both easy today. I just need to find where my bug is. So day 12, I'm not sure what the part 2 is going to be. Part 1, I'm doing it using like dynamic programming. I mean, right now it's basically the brute force recursive solution. So like I tried to solve the the 12 was the hardest so far. Yeah, it seems like it, I mean, at least for the part 1, you could just like try all the different variants, because the maximum length, the maximum size of the map is like 20, so 2 to the power of 20 is not that big of a number. But I'm not, I don't even know what the part 2 is going to be, so maybe part 2 is where maybe part 2 is where we will need to think more. Right now, like I said, I'm just doing it recursively, trying to like feel the map from the very beginning, and trying to currently satisfy the group at this position, and like going forward. And I'm currently having on my left a group of the current size, right? So I'm trying to either make the current cell broken or operational, if I can, depending on what we have on the map. If it's unknown, that I can make it both broken and operational. If it's broken, then I can only make it broken. If it's operational, I can only make it operational, right? So, and then based on whether or not the current thing is broken, we either continue the current group of broken things, or we complete the group of broken things. And in case we are completing a group, it should be exactly the group that we needed at the current position. So yeah, right now, I don't see the bug immediately, but I do see that my thing doesn't work properly. Let me try maybe doing some simpler examples. Sometimes that helps. We can do something like $1. This should give me one way of doing that, right? That's right. If I do a dot 1, then it should be 0, because this one is operational. If I do a hash 1, then it's also going to be 1. All right, and then we do a question mark, and we have 1. This should give me 2 ways of doing the broken thing. It's either the first question mark or the second one. But I only get the 1. So here we go. We have a problem. Now the question is, what exactly is the problem? Dot question mark. Okay, dot question mark is saying that it is 0. Dot hash is also going to be 0. Okay, I see it. I think oh, if I, okay, hold on. I know. This if is incorrect. If I have not completed a group, because I did not have a group, then we do something else, basically. So here we go. If current group size is equal to 0, then it means that we did not even start a group, right? And we're just going to calculate the number of ways to go forward with still the same group, and current group size is still 0. Yeah. Okay. Otherwise, if it's not 0, then the completed group is the current group size, and we needed that. So this is our currently completed group, and it must be equal to the group that we needed to complete, which might be nothing. There you go. So now we actually have completed the group, and we do +1. Okay, this actually makes it look easier. There you go. 12. 21, yeah. I just modified the example, which is why I have a different thing. But yeah, the problem is that before I was like, after seeing a dot, I was going forward, so like my previous group was nothing, and but the group that I needed to do was something, right? But I didn't need to check that, like, if I'm not completing a group, that I should not be like stopping if I still need to do more groups, because I might start that group that I need to complete a little later. So that was the bug. Okay, so there you go. Now we have solved it. Let's remove the printing, and let's solve this for the actual input. All right, it looks like I'm running in debug mode, and I did not even add memoization here. My solution, we could add memoization here, and then it's going to be like very fast, but the input is pretty small, so just the recursive approach of trying all the different things works here, it seems. If this is the right answer, which it should be, it is. Okay, nice. Let's see what the part 2 is about. As you look at the field of springs, you feel like there are way more springs than the condition records list. When you examine the records, you discover that they were actually folded up this whole time. To unfold the records on each row, replace the list of springs conditions with 5 copies of itself, separated by question mark. Wait, what? So hold on. To unfold the records on each row, replace the list of spring conditions with 5 copies of itself. Oh, so like dot hash and then question mark, dot hash question mark. Okay, oh, I see. So like now you cannot do the brute force approach because it is going to be like too much, right? So the only thing that is different now is the way we're reading the input, basically. I did not read to the end, but that's what I'm assuming. So here we go. We have that, right? We have that, but I'm just going to how many times did they say? 5 times? Five copies of itself, right? So I'm just going to make this into a cycle. No. Let's just repeat this. Std iterator repeat. Repeat this thing 5 times. And then we flatten. And that's our actual thing. The only thing that we're repeating is not just the map, but the map separated by a question mark. Can I do an iterator which is like joins the other instead of flattening? Can I do join? Inside the iter tools, there is such a thing, but it is only for strings. Can I do the joining of the iterators of other things? I feel like that's a useful API to have the join on the iterators. Merge join by, what is this? Create an iterator that merges items from both this and the specified iterator in ascending order. No. I mean, I can make it work without the API like this, but it's not the first time I wanted something. Something similar. It's like flattened, but with the element in the middle. All right. Well, whatever. Chain. Yeah, I can do chain, but like if I chain it, then I'm going to have it also in the end, and I don't want to have it in the end. I only want to have it in the middle, right? Like I can do something that's repeated by chaining my actual map with the question mark, which is like the unknown state, right? But that gets me another question mark in the very end, and that's something that I don't want to have, right? So I need to remove it later. But instead, we could have an API which joins an iterator of iterators with another iterator in between of every iterator of the iterators that we join. You know? All right. I mean, I can just do something like interleave is... No, interleave is a different thing. Interleave is like joining two iterators together by having first an item from the first iterator and then from the second iterator and then from the first and then from the second. That's not what I want. I want something like joining the strings, right? Yeah, I am using iter tools and I'm like trying to see if it's there. Join takes t. Wait, does it? Maybe I'm using the different join. Okay, so the problem with this though is that this is a method on a slice. This is not for the iterators. Like I want this API, but for the iterators, if you know what I mean. Yo, Cakes. Hello, bro. Thank you for the raid. I'm doing the Advent of Code. showing off my big brain to the people here today by solving the hard problems easily. You know? How was your stream? But yeah, the API for joining this is for some reason is only a method on a slice. And I would like a method like that on an iterator, which is going to like construct the iterator. Okay, well, I mean, I'm just going to be able to work without it anyway. So here's our map originally, right? We have the hashes, which is the broken pipes. The dots are operational pipes. Question marks unknown. Why take 5? Because I want to repeat it 5 times, right? So in order to repeat something multiple times, you do iterator repeat. Like 0, take 5. This is going to be an iterator, which gives you like 5 zeros. So I tried to repeat my map 5 times, but then the problem is that I don't have a nice API for putting the question mark in between those parts. I was complaining a little bit about the APIs here, that we don't have it. Okay, but let's just do it manually, I guess. Let's just do it manually, I guess. So we just do 5 times. Maybe this is going to be easier to understand if I just do a loop 5 times here, right? I basically extend the map by parsing it again. Sure, why not? And then in the end, I also want to push the operational one. That's like a hack for my algorithm that I'm using. What's wrong here? This delimiter might not be properly closed. Yeah, sure. So like if the index is not 0, then it means that we are in between, so I'm pushing the question mark, which is the unknown state here. And then we just solve it. So this should work, but my recursive approach currently is probably going to work too slow, right? It's going to work too slow, but my solution is actually already pretty good. The only thing to make it run a billion times faster is to add the memoization to this recursive function, so we don't solve the same thing multiple times. Basically, the actual like time complexity of our algorithm is going to be the map size, which is 20 multiplied by 5, I guess, because we did it 5 times here. So like 100 multiplied the number of groups, which is like, I don't know, 10, so like 1000, and then multiplied by the current group size, which is going to be like, I don't know, at most another 100, which probably will never happen anyway. So it's like 10 to the power of 5 to solve one, and that's like very rough estimation. It's probably a much smaller than that. There is one that's 2 power 64, the number of ways. Yeah, but I'm solving the thing partially, you know. I'm like, this is called like dynamic programming, you know. We like, in order to know the solution for the entire map, I want to calculate the solution for the part of the map which is like 1 tile smaller, right? And everything. I mean, okay, you know what is dynamic programming, good. It's just, it's already, so like, the way I like doing my dynamic programming is by doing the recursive function and adding memoization on top of that, because I don't know, it just feels very easy to think about this for me, because we only calculate the states that we can reach, you know. So the memoization is going to be just, let's do a hash map here from the from 3 U sizes, I guess, into the calculated, which is U64. There you go. So here's what we're going to do. The key for memoization is going to be map position, group position, and current group size. So like all the arguments of the function. And if we have already calculated the function for these arguments, then we're not going to do it again. So if it does not contain the key, only then we're going to calculate it. So over here, I'm going to say, instead we insert for the key the thing that we have calculated here, and then now it actually is contained, and we can return it. Okay, the only thing is in Rust we have the borrow checker, which is going to complain, which is interesting. Why are we not complaining here? Because there's another problem in the other way. So yeah, over here, in order to modify this, we need to have mutable access, but this is a recursive function. I'm not going to do that. I mean, will I? I guess I can just... In this specific case, I think I can just take a mutable reference here. But sometimes I just do a regular reference and wrap this into a ref cell instead. And then contains key followed by insert, which is, sure, we could use the entry API instead, but I'm too lazy. Let's just run this. If you do the get with an if let, you can handle both cases in one go. Yeah, I know, but the thing is, contains does a get anyway. Yeah, I know. I was about to wrap it into a ref cell too, and I don't know. I just like structuring my code this way when doing the ref cells. But I guess we can also do the entry API here, because if we don't have the key, like you see this warning here from Clippy. I guess let's do this. We get the entry for the key, right? And then we're going to match on it, and then it's either occupied or vacant. So like if it was not calculated, then we're going to insert it there by calculating the things, which we're doing here, right? So we just do entry insert current. There you go. But the problem with this approach is that now I cannot do recursive function like that anymore, because yeah, we have the borrow checker problems. So actually no. Wouldn't it be better to pass memo as a parameter? Yeah, probably. I mean, when you do it in C++, you just have this as a global thing, especially for a one-off solutions for problems like this. Instead of making this a method, I can make a function which takes the map as an extra argument and the groups as the extra arguments, right? But yeah, this is Or I could use something like like a static thing, like you would do in C++. It just requires more work than you would in C++ because of the checks. I don't know. I feel like that's okay here. Try this. Yeah, I tried that and it doesn't work. You're gonna pass the memo as mute. Yeah, I know. But why? But why? Like, I don't like having another argument here. It makes more noise when I'm calling the function. I need to pass it, and it's annoying, in my opinion. The only arguments that actually matter, that are, like, being different, is those three. I think it would be nicer in once again, I am thinking about a language, a potential language that would be working with algebraic effect systems, and then it would be looking much nicer. Instead of storing... Anyway, day 12 is, I think it's done. We just did not check that our answer here is correct. That's not the right answer. Okay, well, my answer is not correct. Did I check for the example? For the example, the answer is 0. Amazing. That's definitely not true, right? Okay. Did I, like, break something when I was... We don't have a key, then we're inserting... Wait, what is this warning again? Map entry. Just going to allow this. It's annoying. Is the cache per line? Otherwise, you will need to clear it before everything you solve. I'm constructing it for every line, the input and the cache. Yes. Wait, hold on. Well, for this example, I think the answer is 0, and that's right. Do we have the good example? Oh, wait, I need to replace the list of the groups with 5 copies of itself. That's something that I did not do. There you go. I just did not read the problem description to the end. Okay, so the groups, this thing is something that we can just repeat itself 5 times. So I'm just going to repeat this thing 5 times. Certain people or person in chat like to join Rust streams, like pseudo helpful comments to inflate their ego and never follow. Wait, yo, Brook Zerker, thank you for the raid. Wait, what? Certain people chat like to join Rust streams? I mean, it's okay. Not sure what exactly are you complaining about. Sometimes people have some knowledge of some API that I'm not aware of when I'm like complaining that the API doesn't exist. People come and they say that it actually exists. It helps. Anyway, Brook Zerker, how was your stream? Thank you for the raid. We're doing the Advent of Code today. This is day 12, which I think... so this is for the example, 5.2, 5.1, 5.2. Is that the correct thing? Yes, it is. All right. So now we just do this for... Now we just do this for the actual input. And this is the actual answer. All right. My bad. I did not read the problem description to the end, which is why we did not get it first try. But anyway. Easy. Stream was good working on you and web dev in Rust. Nice.
Hello there.
Hello, Bigorly. Hello, Albert Larson. Okay, there's one more day of Advent of Code that we need to solve. The day 13, right? And then day 14 is tomorrow. Okay. Day 12. In case anyone is interested in seeing these solutions in Rust. This is on my GitHub. I can spell Kuviman, Advent of Code 2023. All right, let's do it. Day 13, this is the last one. Point of incidence. With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. There is just one problem, you don't see any lava. You do see a lot of ash and igneous rock. There are even what look like gray mountains scattered around. After a while, you make your way to a nearby cluster of mountains only to discover that the valley between them is completely full of large mirrors. You have more patience than I do, I guess? What do you mean? It is too boring for you to do the Advent of Code, or are you saying like patience for the people in chat that are trying to say things? I don't know. It's okay. I actually enjoy being distracted when I'm working on something. It lets me reset mentally for a little bit, I guess. After a while, you make your way up to a nearby cluster of mountains only to discover that the valley between them is completely full of large mirrors. Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction. As you move through the valley of mirrors, you find that several of them have fallen from the large metal frames, keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one color, it's hard to tell where it's safe to walk or where you're about to run into a mirror. You note down the patterns of ash, dot, and rocks, hash, that you see as you walk. Your puzzle input. Perhaps by carefully analyzing these patterns, you can figure out where the mirrors are. For example, to find a reflection in each pattern, you need to find a perfect reflection across either a horizontal line between the two rows or across a vertical line between two rows. In the first pattern, the reflection is across a vertical line between the two columns. Arrows on each of the two columns point at a line between the columns. In this pattern, the line of reflection is the vertical line between columns 5 and 6. Okay, so like what we need to do here is to find the reflection line, right? Or what? This pattern reflects across the horizontal line between rows 4 and 5. Row 1 would reflect with a hypothetical row 8, but since it's not in the pattern, row 1 doesn't need to match anything. The remaining rows match. To summarize, your pattern nodes add up the number of columns to the left. Add up the number of columns to the left of each vertical line of reflection. So we need to find all the possible positions of the lines of reflection and add up the number of columns to the left of each of those lines, and also add 100 multiplied by each the number of rows. For the okay. In the above example, the first pattern's vertical line has 5 columns to its left, and the second pattern Horizontal line has 4 rows, so the total is 405, yes. Find the line of reflection in each of the patterns of your nodes. What number do you get after summarizing all your nodes? Yeah. So this is the example. We just do the brute force here. Wait, hold on. The example is, well, actually it's 2 test cases, right? 2 test cases here. It's 2 examples. This is the one and this is the second one, right? When am I making games again? Soon. I don't know, maybe we tomorrow make a game. Continue working on Linksider. Should probably do that soon. Day 13. Example. So from what I understand, we have the input, which is a vague list of maps, where map is basically just a 2D array of characters, right? So we're going to read to string input day 13 example. Then we're going to split that using 2 new lines, and we're going to map those into lines. Every line is going to take the characters, collect it into a vec, and we collect that, and then we collect that. All right. So there you go. Now we have the input done. Let's also download the actual puzzle input. Day 13. Okay, so do we just brute force this? Do we just brute force this? There is potentially multiple different reflection lines. Like if the map is fully the same, for example, right? So answer is we just iterate over the input, and then we solve every map, and then we add those things together, right? The number, whatever, just do this. Let's do U64, sure. So solve is a function for the map, which returns the thing that we need to calculate, right? So we do solve for the axis of the map, which is going to get us the, I mean, hold on. Solve for the axis. The map size is going to be map length and map 0 length. This is the number of rows and number of columns, basically. And then for x and y, I mean for row and column, we are just going to get map at row at the column, right? So this is we are going to solve it on one axis, and then we're going to solve it on another axis by swapping what is the number of rows and what is the number of columns, and indexing differently here. because the first argument is going to be the column and the second is going to be the row, basically. And this axis is basically we're going to solve it, let's say, for the columns, right? So the second one, when we swap the rows and columns, is going to be actually for rows, so we multiply this by 100 and we add those things together, right? So solve for the columns is going to take the map. No, not the map. Rows, columns, and the actual map in the form of a function, which takes the indices of the row and the column and returns like the character. Do you like to be helped with this or not? There's a lot of info in the text that limits the cases that you will encounter. I mean, I don't feel like I'm struggling, so I mean, there was so far one day where there was a lot of information in the actual input, I guess. Is this another one of those days? A lot of info in the text that limits the cases that you will encounter. Day 13. I'm not sure, like, do I need to limit the cases? I mean, right now this is only like 2 symbols. I'm going to solve it even more generic by like I'm just doing it for any rectangular map, basically, of characters. I don't even need to know that this is ash or floor. Unless I'm not understanding the problem again, which can happen. It happened before because I am trying to read it quickly because I don't like reading. Can happen for sure. Okay, so we just solve for the column. So I'm going to basically just iterate over the mirror column and see what it can be. And are we supposed to... The vertical line of reflection is not going to be at the edge, I'm assuming. So mirror column is going to be either 1 or it's going to be like less than the number of columns that we actually have. Some of the prompts have been so long. Yeah. Do you even remember the story of the advent of code? What is actually happening? Some elves, some islands, the metal island, something gears to the desert. I don't know what's happening. I forget it all. So over here we just check if we are mirrored or not. So if mirrored at this column, then we add to the answer the column itself, basically, because that's the number of columns to the left. So mirrored or mirror column is going to be what? I'm going to basically iterate for column in 0 to the mirror column, right? Mirrored is going to be mirror column plus times 2 minus column, right? That's how you mirror around this thing, right? So it's the if it's equal to the mirror column minus 1, I think minus 1 is also what we want to do here, right? So if we were mirroring around 2 and our current column is 1, then we should become 2. So there you go. And then we just check for row in 0 to rows if map at row and column is not equal to map at row and the mirrored column, right? Then we return false, otherwise we return true. The only thing is this can panic, obviously, right? So at a row and column should be only checked if mirrored column is less than the columns, right? So we are not out of bounds. Only then we're actually going to do the check. And that's the entire solution here. J13 part 1. Yeah, sure. We convert that to the U64 mirrored. Maybe not a good choice of names here for the variables, because mirrored and mirror column are very similar. Almost made the bug because of that. The length is 9, but that is 9. Hold on, row and column. I still did out of bounds. I still did out of bounds. Mirrored. Okay. If mirrored. I did it again. Yeah, see? The problem is that this is what we mirror around. Column. Like this is going to be... and this is the actual mirrored column, you know? This is the column, this is the mirrored column, and this is what we are mirroring around. That's better names, right? Okay, 405 is what we get for the example, and then we just do it for the actual input. This is what we get. Should be the correct answer. It is. Continue to part 2. You resume walking through the valley of mirrors and smack run directly into one. Hopefully nobody was watching, because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge, exactly one dot, or this should be the opposite type. In each pattern, you will need to locate and fix the smudge that caused the reflection line to be valid. So like now we can mirror properly if the number, so we calculate the number of incorrect positions, right? Incorrect 0, and over here, instead of returning false immediately, we are going to do incorrect plus equal 1, right? And we are going to return in the end incorrect less than or equal to 1, because we can allow for one smudge, is what they call it, right? Let's Control Z this though, because I was supposed to do it in another file, part 2. All right, so now for the example, it is 805. Well, hold on. Why is it 400 now? Oh, it should be exactly 1, right? It should be exactly 1, not 0. Exactly 1. So it's not less than or equal to 1. It is exactly 1, right? And now it's 400. Okay, there you go. Okay. This was one of the easiest ones. I guess the hardest one so far was what? Day 12? I mean, day 12, I guess. Probably. Yeah, this one, because I did dynamic programming. If you do it without dynamic programming, there probably still... Is there other solutions to this other than dynamic programming? Not sure. There was another one which was kind of like funny. This one is not the easiest one too, day 10. The other ones I don't think I even remember. Oh, this one. This one required you to know the to see the input. All right, anyway, the advent of cold is now solved. It took us 4 hours and 20 minutes to solve everything from day 9 to day 13. So we solved 5 days today in 4 hours. Easy. All right. What do we do now? Is there anything else we do today, or do we end? Do we end on this point? There no one else? Oh, wait, hold on. Advent of code, tag 13. Why could I not search for this? This is not English though. Advent of code. Why am I not seeing anyone who's live doing advent of code? Is my Twitch search broken? Is my Twitch search broken? What? Oh, there you go. It's here for some reason. Because advent, and it's like giving me the adventures. The adventure streamers. All right. All right. Anyway, anyhow, guys, in case you are not familiar with our channel, we usually do the game development here. We made a game for the Bevy Gem a couple days ago. Looks like this. And we're going back to the game development. And going to continue work on more games soon. Advent of Code is just like a funny side thing that we're doing, you know? Most of the time we're doing game development, participating in game jams and things like that. So yeah, that's what's going to happen tomorrow. There is someone who's doing Advent of Code.
But that's where I was going. It's slice 2.
It's in JavaScript. Nice.
So yeah, inputs is now just the route to go.
Oh yeah, this one was funny. All right,
Um,
let's see if they can solve it. Let's go raid. See you guys next time.
Let's say
Bye.
node equals an object. Inputs dot for each input